Well, last presentation of the day here. I hope you guys have all had a good time at DevCon, or Big Sky DevCon. I definitely have myself. A lot of interesting talks, and hopefully this talk kind of ties in with a little bit of what's been said in some of the talks, especially the one by Ryan that he gave earlier on managing old code. So my name is Olszowka, and I'm giving a presentation on an internal tool that we call Tattletale. It's a presentation called Tattletale, Know Who's Breaking What and When. So let me first talk a little bit about Computers Unlimited. We're founded in 1978 in Montana. Believe it or not, we were actually founded here in Bozeman by Mike Scher. He was a professor at MSU before he decided to move his company to Billings in the early 70s. We're currently based in Billings, Montana. We have about 190 employees, and about 90 of those employees are developers. Our primary product is a software package called TIMS, and it's an acronym, stands for Total Information Management System. We target the industrial gas and welding supply distributors and home medical equipment. So basically everything you need to run your business, everything from order entry, which is kind of like a front a point of sale device, basically everything, general ledger, accounts receivable, purchasing, blah, blah, blah. A little bit about myself. I graduated from Rocky Mountain College. I have a BS in computer science, probably like a lot of you. I also have a minor in business management. I started as an intern at Computers Unlimited as a what we call regression testing, which is basically automated UI testing. I've been the build master there since 2010. When I took it over, we really didn't have a formalized build master role. I kind of filled that and basically was responsible for a lot of the automation. Please feel free to stalk me on GitHub. I love contributing to open source projects, especially anything around DevOps and anything that Microsoft has kind of open sourced, especially MS Build, because that's my world. So you can see me there, you know, yelling with everybody else at Rainer, Sigwater, and all the other cool guys at Microsoft developing all our code for us. You know, Microsoft Certified Solutions Associate, as most developers are at CU these days, and I'm a Simpsons fanatic, so I'll have a great picture of Ralph here waving his hand. So a little bit about Tattletale. A lot of people have asked, you know, well, why did you choose the name Tattletale? You know, we all know kind of the dictionary definition. I really like the Urban Dictionary definition personally. Tattletale is a sort of self-righteous person who complains about you every time he catches you doing something you shouldn't do. They're all very annoying. Well, we're going to talk about tattling and why it's not a bad thing. So what are we talking about? As any software project grows, patterns and practices emerge kind of gradually over time. And a lot of times when you're in greenfield development, you don't really think about it. But if you look at Computers Unlimited, our software, some of the oldest parts of our code probably reach all the way back to the 70s. So we're working with over 40 years of code. And over that time, you know, it's a lifetime. It's older than me. It's amazing to work on software that's older than yourself. Over that time, there's been a lot of knowledge that's been gained and a lot of patterns and practices. And because it's been around so long, the turnover on the team is very, very high. You have a few people that have been at CU, maybe from the early years, maybe 35 years ago, but you don't have anybody that's been there from the beginning. So as the product gets older and as the product grows, the gap between a senior and junior developer becomes very, very large. And I can't tell you how many times we'll get a junior developer in and he's got all these bright ideas and it's like, this has been tried before. Believe it or not, I firmly believe that there is no original content. Everything's just a rehash of everything. And those who fail to understand, unfortunately I cut off my little quote here, but those who fail to understand history are doomed to repeat it. So how do we solve this? How do we solve it in the cheapest, most efficient way possible? Well, the answer is automation. Like a lot of things that have happened in the last 5 or 10 years, everything can be automated. And what we're going to do here is we're going to apply continuous integration to implement gatekeeping on our code. So if you aren't familiar with continuous integration, if you Google continuous integration, you're going to see a graph that looks a lot like this here. You've got your developers working all day, every day. They're going to check in changes to your source control server. You're going to have some kind of continuous integration server, fetch the changes, build, test, succeed or fail, repeat in a tight loop, right? So if you don't have this process, you should really get that process going. So, we started asking the question, well, what if instead of just building our code, we also started automating the cleanup thereof, or the processes we forget? Anytime we produce code, a lot of times there are things that we can automate, and we're going to talk about that here in the next slide. So what kind of stuff can we automate? A lot of these things I'm sure that you're going to run into here. I mean, tabs versus spaces and line ending consistency. This is a holy war that will go on, it's gone on since the beginning of time. It will go on long after we're gone. But these are things that we can very, very easily automate. And, in modern times, stuff like, Git, for example, has fixed a lot of the line ending problems for us. So long as your Git settings are correct, you're going to get right line endings. Stuff like naming conventions, pattern enforcement, API compliance, compliance and API restrictions, processes and procedures, ensuring that interops are regenerated, ensuring that the right libraries are used, and keeping test data updated. These are all processes, and as your product gets larger and larger, these processes become more complicated, and as the code base gets larger, it's really, really easy to forget that you broke something way out in Timbuktu. I mean, I don't know how large any of the code bases you're working on, but Tim's itself, I think the last time I looked, we're at like 60 million lines of code and something like, 100,000 or 200,000 files. Nobody in their right mind is going to go through every single one of those files. So what you really got to do is kind of automate that. But anytime you're going to go and automate this process, you're going to hear a whole laundry list of excuses. But I never make a mistake. I don't care who you are. You could be the absolute best developer in the world. I think the best developer you've ever known, they're going to make a mistake at some point. They're going to forget some process. If we put this process into a continuous integration server, we have something that is going to give us consistent results. He's never going to make a mistake unless we have an incorrect configuration. And there was a great lightning talk that talked about, he was calling it GitOps, but essentially that's what we're doing here. A lot of people will also complain saying the IDE already does it for me. Well, guess what? We live in a very diverse world, very big world. Not everybody wants to use your IDE. Internally at Computers Unlimited, us being a Microsoft shop, we're very invested in Microsoft tools, so most of us run Visual Studio. Well, there's a significant portion of our developer base who, these guys are programmers from the 80s and 90s here. They're like, what is Visual Studio? I don't know what this is. I'm going to go open up VI or, Sublime or Ed or something weird. Who knows what they're doing? But they're going to go open this up, and they're not going to have all this great, powerful tooling that we're used to. And all the time we get issues from them. They've got a tab, they've got some weird, line ending going on, whatnot. And the last excuse we'll hear a lot is that it's not important. Well, unfortunately, as your team gets larger and larger, and as your code base gets larger and larger, if you don't have consistency between that, you get into all kinds of editor wars. And I will admit that in more recent years, it's gotten a lot better with most of our version control tools. They can handle most issues, but a lot of times, if we can keep consistent, we make it really easy for our tools to handle any kind of merge conflicts. So let's talk about this here, the old new thing. So the idea of automating our validation process is not a new idea. In reality, this has been around forever. And where this idea really comes from is, I remember reading an article about, maybe a year or two ago, Facebook said, hey, we've got this really cool, AI system here that does your coding for you. And, you start reading this article, and then you come to realize all they've really done is taken their existing validation processes, put it under some kind of CI server, and then just automated the check-ins thereof. It's like, well, I can build something like that. That's no big deal. So all we're really doing here is we're just continuing to push CI harder, better, faster, stronger. So I've sold you. So what actions do we need to take? So before you implement any kind of process, any kind of Tattletale process, there are a couple of requirements. The very first one, and we're going to go into each one of these in depth here, is a good understanding of your rules. You need to have your code under version control. I mean, it's 2019. I'd hope that everywhere you're working has version control, but I've seen some pretty scary stuff here. And remember, copy and paste and making a duplicate of your code on a share. That's not version control, guys. That's hoping that nothing comes away. Some kind of continuous integration server or pipeline. Item-component tooling, we're going to talk about that. It's a funny word here, I probably said it wrong. We need to make it fast, and we need to have continual improvement. So understanding the rules. I don't know, none of you must be Judge Dredd fans here, otherwise you'd recognize this quote, "I never broke the law, I am the law." We need to understand the rules, and any company you work for is going to have some kind of house rules. The most common ones that you're probably going to run into is, hey, we use spaces instead of tabs, or we use tabs instead of spaces, or we use carriage return line feed for our line endings, or no, we just use carriage return, or we just use line feed. Stuff like naming conventions, it's like, we demand that everybody use Pascal case, and now we've got to go rip through all our code and replace everything with Pascal case. API usage, this is a big one. So many times as code evolves, and it was talked about in one of the presentations that was given here, as your code base evolves, various APIs are determined to be bad. So a real common example I like to use is nowhere in our code base should we be using parse. Parse is totally unsafe. We can put all the warnings in the world, but unless we have some process that's sitting there constantly monitoring the code, we're guaranteed that someone's going to try and insert parse. Compliance. We also want to make sure that there are no hard-coded strings, and I can think of all kinds of things. But basically, what we're asking is we're asking to write tools and tooling to kind of define what our exclusions are. And that's kind of weird wording. I obviously didn't study that. So this is a great graph that was made by one of our architects internally at CU. And where it comes about, a lot of these kind of rules end up getting involved in a holy war, right? I mean, tabs versus spaces. And his point is, and the reason I love this graph is, we've got two options. We've got option A and option B. It really doesn't matter if we choose option A or option B, but if we're inconsistent, our productivity drops drastically. So we need to choose either option A or option B and stick with it. I've often said that if you develop in a system that's constantly crummy, it's going to be a lot better than if you're developing in a system that's sometimes crummy and sometimes good, because if it's always crummy, you don't know any different, right? Or better yet, if it's always crummy, it's really easy to go switch it back to make it not crummy. So for example, let's just use a real simple one, tabs versus spaces. Internally, our developers love using tabs. I hate tabs. So, but because it's all consistent, I get to have my cool little tool that goes and converts all the tabs to spaces, and then right before check-in, converts it back to tabs. So a lot of these rules can be enforced by something called static analysis. And most of you have probably heard about it, what static analysis is, but I'm just going to give the quick recap. Static analysis is the idea that you can analyze source code and then apply a set of rules and patterns to identify a potential issue as early as possible in the process. And a lot of this is really language dependent. For us, fortunately at CU, I wouldn't say the majority of our code is written in Dieball because it's 40 years old, but a lot of our newer code is written in C#, and C# has a very, very powerful static analysis library. A couple of years ago, they rewrote the entire C# compiler into a new compiler, codenamed Rosslyn. And Rosslyn basically treats the code as it gives you the ability to write code, if that makes sense. Think of it almost as like having the, I'm thinking that like the closest equivalent might be maybe like a document object model in HTML, a DOM. And the idea here is that if we do static analysis and we have these patterns, we can write tooling such that our results are consistent and automatable. So the example I like to use is recently we converted from NUnit 264 to NUnit 3. And anytime you're making that big of a jump, a lot of times you have a lot of breaking changes. So one of the biggest breaking changes is they removed, they changed the API for exception handling. Well, we did a quick search of our code, and I think we had something like maybe 25,000 or 26,000 places that use this old API. Unfortunately, that API was totally gone. So it's like, well, we can either keep using NUnit 264, which is in this old crummy library, or take all the time to rewrite all 26,000 places that were using it. Well, thankfully for us, somebody had written a Rosslyn Analyzer that basically said, okay, I'm going to take your code and I'm going to perform a transformation on it that's going to rewrite anywhere I see this, this usage of the API in this pattern and replace it with a similar pattern. And I can't tell you how great that was. Now, it wasn't 100%, but it got us very, very close. And the point I want to make with that is, if we get in, a lot of times you're eventually going to find yourself in a system that's too large to handle, and you're going to want to quickly transition to a new library. If you have the ability to quickly rewrite code using static analysis tools, that's very, very powerful and allows you to move very, very quick. And I've just kind of given a couple of examples of static analysis tools: StyleCop, FXCop, Rosslyn Analyzers, Lint, if any of you guys are old school C, C++ programmers. Editor config, I put that on there with a star. I'm assuming most of you are familiar with editor config. If you're not, you should go take a look at it. A lot of IDEs support it. Visual Studio Code and Visual Studio allows you to kind of automate some of these rules. So the next requirement that we kind of need is version control. SVN blame tells no lies except when it does. So version control is the absolute bare minimum. I like to bring this up. Back in 2000, Joel Spolsky, and I probably mispronounced his last name, but he had a great blog called Joel on Software. And in there's this classic post, so you can look it up on Google when you have some time. It's called 12 Steps to Better Code. And in there, he kind of lists out basically the 12 things any competent development shop should be doing. And I want to say either number 1 or number 2 was having version control. And honestly, if you don't have version control where you're working, if you take nothing from this conference, take this, go home tomorrow, and just put some kind of version control. It really doesn't matter what you use for this concept here. You can use Git, Subversion, Mercurial. It's absolutely critical to understand when an issue was introduced and by who. Because the idea is, if we start from a good state, so let's just give a concrete example. If we take we have a text file, and we know that this text file has all spaces in it. If we run this in automation, and every commit it's checking saying, does this file still use spaces instead of tabs? Does this file still use spaces? As soon as somebody checks in something that uses tabs, you immediately know, hey, the guy that broke this was on this commit, and then we can quickly go back. And I mean, that's just the most benign example. This can be extended to just about anything you can think of. Keep going here. So continuous integration server, that's the next requirement. Or in Newspeak, I don't know if any of you are 1984 George Orwell fans, pipeline it. It seems like every 3 years we come up with a new name for something old here. I mean, I'm going to continue to call it a continuous integration server. There are lots of options out there. We use cruisecontrol.net, one of the, probably older and definitely not one of the first, but definitely an older software package. If we were redesigning this today, we'd look into Azure pipelines. Bottom line is, we need the ability to script out tooling. So most continuous integration servers, the easiest way to think about them is they sit there and they're waiting for some trigger. It's like a cron or Windows Task Scheduler on steroids. And in our case, we're asking cruisecontrol.net to simply sit and look at our Subversion server and just wait for a change to happen. As soon as a change happens, I want it to kick off a process and then report me the results. That's all we're looking for. So idempotent tooling, what is this funny word? Like I said, I'm probably saying it totally wrong because I just heard it pronounced a different way in the previous presentation. But idempotent tooling, for our purposes, we're defining idempotent tooling as if I'm given the same input, the tool produces the same output. So one way to think of this, and one way I've tried to explain this to others, is if we think about multiplying something by 1. It doesn't matter what input we give it. We can continue to multiply this by 1 and we're going to get the same result out of it so long as we don't change our input. So if you multiply 1 by 1, it doesn't matter. You're going to keep getting 1. Well, if you give it 2, now you're going to get 2. Now you know you have a change. So to kind of bring this back to our example, if I run a formatter over a document and there were no formatting changes, then nothing has changed. So if you're creating tooling that if I run it over my document and it changes every single time, something is probably wrong with your tooling and you really need to go fix that first before you can implement this idea of tattling over a particular process. Same deal, another example I give here is if I run a file listing over a directory and nothing has been added or removed, the listing should return the same value. And I put this here, including ordering. The whole concept of this here is that I'm going to run a tool and I'm going to compare what I had previously to what I have now. If nothing's changed, I'm okay. If something's changed, I can figure out who committed last and made a change. So next step is make it fast. Ain't nobody got time for that. So a lot of the problems with this stuff here comes back, you want feedback as soon as possible. Ideally, in a perfect world, all of this validation would have happened in the IDE. The API checking would have happened in the IDE, but like I've discussed earlier, not everybody is using the same IDE. Where it gets a little more difficult is when you have unintended consequences. So in our system, we unfortunately have this global structure, it's called the repository. And in the repository is a definition of every single field that we have in the system. Well, unfortunately, if you change one of the names in there and you just didn't happen to compile everything, well, you're not going to find out. Well, normally the continuous integration server, the build, is going to kick you out there, right? Well, where it gets even more kind of devious is if you have interop code that's not generated all the time, and that person forgot to go generate that interop, he's not going to get burned. Nobody else is going to get burned until they actually go run it at runtime, and it's like, well, what's this field name? Who's usually going to get burned is the next poor sucker that's in there and generated the interop code. And I can't tell you how frustrating it is to go in and regenerate some interop code to find that somebody changed a field name, and then now, in addition to your change, you've got to go fix everywhere where that guy didn't go fix. So if we can give feedback sooner in that process to say, hey, you changed the name in this field, and you obviously forgot to regenerate the interop, you need to go fix it. It makes it a lot easier to come back to that developer and say you've got to fix it. And I've listed some other various ways to improve this. So once you have a tattler in place, the easiest way to do it is to remove processes. A lot of times, sometimes in companies we do things just to do things. So a very common example I like to give is at our company we have a process that says every time you make a change in a file, you have to go bump a version. Now, in the 80s, that made great sense because they didn't have this concept of continuous distribution. They didn't have the concept of packaging everything up here. All you had was a version number. And if that guy didn't bump the version number, it was tough sledding out there to know what you had in code. But in doing this process, what we discovered is like nobody uses this version. So nobody really cared because nobody was being told, hey, you got to go bump the version. As soon as we put a tattler in place that said, hey, you made a change and you didn't bump the version, we got people really anxious. And they said, well, why do we do this? And what it really did is it forced management and even our developers, in a sense, to really question, why do we have these processes? And I feel has really improved our code. Faster hardware, obviously, you pay to play, put more cores, put more memory, put faster SSDs, blah, blah, blah. Better training. A lot of times, when we encounter these types of problems, it really does come down to developer training. We have some process out there that's maybe cumbersome, and as we onboard new developers, they're not being told about it, so if they don't know to do it, they're not going to do it. Well, if you have an automated process or a tattler that's going to sit there and tell them, hey, you missed that, it's a way to kind of surface this process and tell developers, hey, this is something that you need to do. And the better part about that, to loop back around to the first point, is it makes them question too, saying, well, why do we do this? And it gives us a touch point to kind of reevaluate our processes. And finally, better developers. Most people take a lot of pride in their code. If they've done something wrong, they want to know immediately that they've done something wrong. And by having this process that tells you, hey, you're missing something, it gives them a chance to improve. Now, if they're continually getting tattled on, well, maybe we got to have a hard discussion, but hopefully not. The last point here is continual improvement. Get busy living or get busy dying. So it's definitely a favorite quote of mine. If you're not growing, you're dying. And when your code bases get as large as our code bases have become, you have a lot of dead code and a lot of dead processes. And a lot of times these processes kind of get swept under the rug because if nobody's sitting there enforcing the processes, they kind of wither away. And for most people, that's great. The problem is when you start to onboard new people and they're like, well, what's all this dead code here? Well, I don't understand any of this stuff. And, you know, depending on who you talk to, oh, we don't do that anymore. Or, you know, I found this random document that told me to do X, Y, Z. I have no idea why I'm doing it, but I'm doing it. You need to continually reinvest in your product. You need to continually fix up these processes. And if you automate the process, in essence, you're documenting the process. And because you've documented the process, hopefully you have an understanding of why you're doing it. And no process is perfect, like I mentioned before. And you need to be open to saying, hey, we shouldn't do this process anymore. This seems ridiculous that we're doing it. We need to pay attention to feedback. A lot of times, the best feedback that you're going to get is from somebody new coming onto the team. There's a great blog post, and I'm trying to remember what it is, but his quote was something like, the normalization of deviancy or something like that. And basically it was this idea that when a new person comes to your company, they start taking a look at what you're doing and they're like, wow, this is crazy here. Why would any company do this? And then after some set period of time, you know, a year or two, they kind of accept the madness, right? You know, they turn into the skid. And then, you know, a new developer comes in and says the exact same thing. It's like, whoa, what is this madness? And, you know, the guy that was there before was like, yeah, we know it's a problem, but whatever here, you'll get used to it. We really need to stop living with broken windows. We need to really pay attention to that feedback and improve the processes. And if we have something automated that's continually running these processes, it's going to show us very, very quickly when this process is not a good idea. And finally, keeping current and getting involved with the community. Like I said, a lot of these ideas of continual improvement of your project, these aren't really new ideas. And this has been a great DevCon that I feel. I'm seeing a lot more of these concepts being pushed out into production, and a lot more companies and people are getting interested in these processes because they're seeing a lot of value in automating the mundane, essentially. And it's a lot easier. A lot of times I've been told that it's easy to point out flaws, it's very difficult to fix them. Well, if we can remove the time that it takes to point out the flaw, we can reinvest that time. Instead of somebody going around trying to find the flaw, we can reinvest that time in fixing the flaw. So let me give you another concrete example. This was a great quote said by one of our architects. I try to fit it in every single one of my slides. It's without numbers, it's just like fishing stories. So here I have a cool little picture of cruisecontrol.net. I mean, this is like almost any continuous integration server you're going to see. And here I have several tattlers. We have multiple, and then checks it right into subversion. So here's a great example of saying, hey, you know, as of revision 181,051, somebody obviously made a commit on here that is modified, how many, 35 projects here got touched by this. And what you do is you get this, pretty cool graph that says, hey, it looks like in CU service clients.csproj, somebody has added a reference to CU utility print job submissions. Well, in doing that, print job submissions contract, has a dependency on CU core shared. And it makes it very, very clear the types of dependencies they're adding and just the amount of ripple that they have. And it's been really interesting for me to kind of show this to people, because I think in our minds when we're developing, we like to think that we're developing these highly decoupled systems and, oh, I'm not affecting X, Y, and Z. And without data, it really is just like fishing stories to me. With this, we can very clearly show that, hey, you're causing massive ripple in the system, and maybe we need to re-engineer your design. And previous to this type of tooling, this would have been a manual process. Our architect would have sat there and maybe once a week or once in a blue moon, he'd go run this and say, oh, it looks like a whole bunch of additional things got added in there. But now, because we run it in automation, we basically get it off of every single commit. So the second example that I'm going to talk about here is Tim's Migrate Tattler. So long story short, schema changes, lots of schema changes. So our product, like a lot of other products, depends on a database. And every day, developers are making changes to our tables. You're adding a column, you're removing a column, you're refactoring, you're moving data around here. And it'd be really, really great to know just how that affects the data set. So there's this great open source tool called SchemaZen. And what SchemaZen does is it takes a look at your T-SQL database. I think they've got MySQL support now too. But basically looks at your database and dumps it to a file. And that's all good and great because we use it to restore, right? Well, let's take it a step further. Let's check it into Subversion. And then let's start seeing what happens. Well, a lot of really interesting things happen. Let me get this to go here. So we've got basically another account called Tattler, and basically every time we have a new production revision, we run our migration process, our conversion process over a set of test data. Then we dump it out, and then we say, okay, what changed? And very quickly, when we first put this into place, we noticed that we were changing places that were unexpected. It's like, well, why is this part of the system being changed? And after digging down, long story short on that one, somebody had a trigger somewhere that they didn't realize. But because it was in this tight automation loop, and because we were continually checking it in, it made it very apparent that, hey, every time you make a change to this, unexpected changes are happening way off in the system. Somebody should probably go take a look at that. So in this case here, this is a TL object version table. This is kind of back to that versioning here. Every time we make a change to the schema, we're going to bump a version, and that version is stored in a table. Well, this is showing me, hey, out of this, after I redumped the database, only one line in this, I can't remember how many lines this file is, some insanely long number. Only one line changed within this tool. And this has been very, very powerful. We have a lot of unit tests. Well, I should back up. They call them unit tests, but what they really are integration tests because they depend on environment setup and data. And all the time we would have just random integration tests fail because somebody added a new piece of data. Well, with this process, it's been very easy to go back and replay the database history and say, okay, what change in the system introduced this error? Who removed the column? Who went and modified the data? So it's very easy to go pinpoint and say, okay, this was the change that caused this ripple. And if it was expected, it was expected. If not, it wasn't. So I know I've kind of ran through this really quick. Do you have any questions, any comments, anything I can harp on?